With commonly used obfuscators like ConfuserEx, there's usually the advantage for you as a malware analyst that there are already solutions out there. So you will find deobfuscators for that, and the idea is you plug the sample in them and it works, right? Well, the reality is a little bit different because others who use these obfuscators are aware of these tools, and what they do is they just change the obfuscation a little bit, how it works, so that the tools don't work anymore. So that's a common problem that you will encounter. The samples I showcased today use something that I suspect to be ConfuserEx2 string obfuscation, but they are not exactly working with the tooling that's out there. So Dump Guy did some awesome work on deobfuscating this using Harmony and ASM Resolver. I will put a link into the video description below for the tool, but also for a Checkpoint article that explains how Harmony works. Might be a good addition to watching this video here. And we will use this tool, we will see it doesn't work, and we will adjust it so it works for our variants. And yeah, see how that turns out. Before we start, I have also two announcements to make. The first one is that there's now an intermediate course on my platform, malware analysis for hedgehogs.learnworlds.com. And I moved the beginner's course from Udemy to the new platform as well. For those who bought the beginner's course already, it stays available there. Don't worry, you will still have access to it. But in the future, you will only be able to buy it on my own platform. If you're interested in chatting with some people who also watch my videos or take these courses, please check out the link in the video description to Discord. We have a Discord server, and yeah, you can find us there. So here we have one of such files, and the strings in here are obfuscated. So we can see whenever there is a string requested somewhere, it calls the very same function, this 0005 method here. And it takes an integer and then returns a string somehow. So this just calls another method, and this does some more complicated calculations to finally return the string to you. It seems that the data or the strings are somehow in the resources. Now, this is something that I have seen before with ConfuserEx, and I was wondering if I can just use the script here, ConfuserEx2 string decryptor. So let's do that. We download the archive and then open this. So, or maybe I should show you, because there's also a release version, right? But so we have here 32 and 64-bit files. This is a 32-bit sample, so I'm going to use the 32-bit decryptor. And now let's see what happens if we run this. It says string decryption methods not found. Did you unpack the sample? So the string decryption, the function that finds the string decryption method, does not work. Let's see if we can fix this. For that, it's helpful to know how the tool generally works. And I'm gonna open this now in Visual Studio. So let's take a look at this script first. So this is the ConfuserEx string decryptor. I think Dump Guy also has some videos on that, so you can check out those videos, but there's definitely a great article on how to use Harmony, because Harmony is the framework that is used here for hooking. ConfuserEx has some anti-reversing detection. And one part of that is that it checks if the calling assembly is the same one as the currently executing assembly. Because of that, it will realize if it's not the same, so not the own application that calls, for instance, the decryption function, then it will just not return the correct string. And this is using a hook here to change the value, the return value of get calling assembly. The way it does this is it installs a prefix hook. A prefix hook is one that executes before get calling assembly is called, but it will also skip the execution of the original get calling assembly function and instead return the currently loaded assembly. This is a value that is saved in the main program here. So the loaded assembly, that's the assembly you're currently analyzing, right? So the file that we want to deobfuscate, this is returned as the calling assembly. And subsequently, ConfuserEx will think that everything's correct and it's the own application that requests the string, and then it will execute just fine. So this is one part of the script that's vital. The other one is the part that does the deobfuscation. So when you check here those nested loops. So this iterates through all of the methods. It then checks if it found the string decryption method. So there is one way where it finds the string decrypt method, which is the first one that fails in our case. And if it finds the instruction that calls this decrypt method, then this instruction will be overwritten with the decrypted string or deobfuscated string. So this is the opcode that loads an integer, and that is the integer that we see right here. So this one. We check in the IL code here how this looks like. Let me find this. So this is how a call looks like. So we have load constant. This is an integer of size 4. And then there is the call to the string decrypt function. Decryptor looks for this kind of instruction combination where you have load constant this and then a call to the decrypt function. So it obtains then the integer and it dynamically calls the decrypt function. There should be an invoke here. Here is the invoke. So this will invoke the method. And because it's dynamically invoking it, the method can also check if everything's all right. So this, the hook needs to be placed there so that this invocation works. So this is a dynamic decryption script and it executes code. So it's not safe to use outside of a malware lab. So how does the find string decrypt method work? It will iterate through all of the method definitions, and then it will check if the method body is not empty. That means it has instructions in this function. And then it will check if there is exactly one parameter, which makes sense because here we also have exactly one parameter, which is an integer. And that's the next thing it will check, that this is an int 32. If that's the case, there is a second check, and this is looking for an instruction that contains get executing assembly. So it's looking for the call to get executing assembly. And the second condition is it checks for get calling assembly. Now let's take a look at our function. the function does not look like that. It only calls try get value. And it calls another internal function. And that function now has get executing assembly and get calling assembly. So we could find this one if we check for 2 parameters instead of 1. Or we can just adjust the condition to search for try get value instead. So let's do this. Let's remove one of these conditions here. So this is this one. We don't need this. And let's search for try get value. Save this. And now we also need to adjust the debug options, no properties, because we want this to run our test sample, which is this one. So getting path, put the path in here. Let's see if that works. So we built this. Now what I would like to do is add some output here to see if we successfully found the method and if we successfully decrypted our strings. So let's do that. Let's print the metadata token. And let's also place something here. And now let's try that. And we can see we found the correct method. However, there are no decrypted strings. So let's see what went wrong. So let's now see where it actually fails to do something. So we can see here a lot of nested for each and if blocks. And one of those is probably not matched. So let me just print some output here. I can already see what is likely the problem. So it's checking if the operand, if transformed into a string, contains this. And this is a generic method definition, which we do not have here. This isn't a generic method, it's a specific method. So that's gonna be the problem. But let me see if we actually get to this point here, and then see how we can change that. Okay. You run this. And we arrive at 2. So there's 1, there's 2. We do not arrive at 3. So this condition here fails always. And why could that be the case? So we can see all that this condition does is it checks if the currently analyzed method has the string decryption metadata token. That's all it does. That means that the methods that we check here are not the right ones. We seem to be checking other methods. So So let's look at the condition in this for each loop. And what we can see here is we check for any method, any instruction that's a call instruction, where the operand has a type method specification. And that's not the type of our current string decrypt method, because method specification is for generic methods. And since this isn't generic, we need to use serialized method definition. So let me change this. Gotta import it as well. So we fix this. And now this should work. We should at least arrive at this point here. Let's do that. And indeed, we arrived there, but we still exited without decrypting any strings. And that's what I already assumed here. This doesn't contain this string because it's not a generic method. So we can forget this condition here. Also, it's not like we have two types of strings here. So let's just remove this. Let's just assume we do have we found everything. So here we are. Save this and run. Now it says invalid operation exception. String is not a generic method definition. Obviously, we have done some mistakes with the invocation here, because invocation also assumes that this is a generic method and then creates a concrete method using the string for the type. We don't need that. So let's just remove this. We just call directly invoke on this value. Gonna restart it. So exited with code 0. Let's print the decrypted string as a control. And run it again. So everything works. However, all of the strings are decrypted to x0x. So this is quite interesting. Now, let me check. I think this generated the deobfuscated code. Yes, here it is. So this is not helpful. We have now created a cleaned file where all of the strings are x0x. And obviously, this is not going to help us to reverse engineer this file. There is some sort of anti-reversing check that we missed. So let's take a look at the code again. But not this code here. This code here. So to summarize, we found the right method. We also invoke the method correctly. We get back a decrypted string, but this sample detects that we call it from a different assembly or that this is a part of a deobfuscation process and not the general execution of this file, and makes our life harder by returning a x0x string every time. Now, this part here took quite a long time for me to figure out, because this code is hard to understand, and I cannot really replicate my process of finding this. What I basically did is step through everything and try to understand it. So I compared the debugging this with PowerShell and debugging this with the nspy, which works. So if you debug it with the nspy, you don't get x0x. And then I compared what the differences are, and I found probably, I'm not sure exactly, but 5 different places that I needed to patch to make this work. And the thing is, I have several files like these to analyze, and I don't want to patch them all manually, which is the reason I wanted to find a more generic solution that works. So let's take a look at one of those places which do the anti-reversing check. And that is here. It's checking the stack trace, and it gets a certain frame from the stack trace. I think it's frame number 0 here. So we have num is 2, -2, 0. And if that's null, so if it's not available, it will check frame number 1. And then it obtains this method from the stack frame, and it will check if the type here, or the declaring type of the method, is of type runtime method handle. And this commonly happens if you use reflection to call the string decrypt method. At first, what I did was I changed the IL code here. You can change this type. Specifically, I just changed this type to any other type, and then it will proceed as usual until you find the next location where the same or similar check happens. Just changing this flag doesn't work either. It will just fail at a different point, because some of those checks, they also influence the offsets that I use to read the resource file and then deobfuscate the strings from them. So let's see how my solution looks like. So the idea that I got to fix this is that I'm also using harmony hooks, but not only on get calling assembly, but also on the functions that return the frame. Because that was the commonality between all those checks, is they call stack trace get frame. So let's just hook this and return a certain different value and see if that works out. Or we can just copy and paste this here, and instead of get calling assembly, we use get frame. And in this case, I would like to change the index. So I don't want to change the result. I want to change, because that's easier, I want to change the index instead. So get frame retrieves an index, and so it has an argument that we receive here by reference, because I want to change it. So this is something we don't need. But what I'm going to do is I say this and change the index to, let's say, anything else. And we print our output here as a control. We notify that we changed the index, and we return to true so that it still calls the original function, but this time with the new index. So this is where the prefix hooks actually are great for, because prefix is ideal if you want to change the input value. Whereas something like suffix you may use to adjust the output value, for instance, unless you do it like this here, where the original method isn't even called. But in this case, we call the original and just change the index before we do that. And then everything else works out just fine. So this is just a test. I'm not sure which index would work. So let's see if any of those work. Now we need to also install the hook. So actually, let me just use the access tools of, I actually looked up how Harmony works, and they have like this access tools function where I can say I want to access method xy, and the method name here, the full name is system diagnostics stack trace get frame. Create a new harmony with get frame. And we call prefix get frame. This should work. Let's see if there's anything different now. We start this. Wait a minute, I think I need to use the full qualified name here as well. Let's do this. Okay. Let's try again. Okay. So I kind of got stuck here because I didn't see an obvious error. It happens. So let's fix this. Let's try again. If that makes a difference. And it does. So just randomly choosing some other index for the stack frame, a fixed one in this case, and now we get our decrypted strings. This is awesome. So several indices work, whether it's 4 or 2, it doesn't matter. If you try one, it works, that's fine. And I also tested this on similar files, and they also get decrypted just fine. So let's take a look at the result now. And that's much better. So now we can see this, and we can now properly analyze everything here. If you want to try this at home, I have a repository on GitHub named Hedgehog Tools, where I publish various scripts, deobfuscation, extraction scripts for various malware families. And you will also find the one that I showed you today. The most important column is the static column. If it's green, you can run this tool where malware should not run, so it won't execute any malware code. If it's red, it's using dynamic ways like our script that we just checked. So this isn't safe to run because it executes the function of the malware. Here are the test samples. I will put a link to them into the video description below, so you can also use them. And yeah, that's it. If you have any questions, please put them below, and see you next time.